Well, I'll get us kicked off, if that's okay with you. I just want to say one thing, and then I'm going to leave it all up to you guys. I'm Marcus Ford. I'm a drive coach, coach of design, a lot of pretty much everything the students need. I try to help with. That being said, our students are absolutely amazing. They take care of pretty much everything, so they make it really easy for to coach this team. They put on this presentation for you all tonight with little to no mentor support. So I'm looking forward to seeing what they have.
All right. So we'll go ahead. We have a slideshow with some information, just about our team and everything, and then at the end we'll open it up to Q&A. So let me get this shared real quick. Mhm.
Before we get into the slides, why don't you guys just introduce yourselves, what division you're from, and kind of what each division means for the team? I know we'll get into the more breakdown, but go for just a general overview.
All right, I'll start. I'm Sierra. I'm the robot operations director, and robot operations just handles everything mechanically about the bot, and we design, manufacture, and assemble the bot.
Hello, my name is Johnny. I am the co-director of programming electrical, and we program the robot and design the e-board and wire the robot.
Glenn, you want to go next?
Sure. So programming, we focus on both the IT and programming the robot. So we use command-based Java with a variety of libraries to do that, including Vision and Swerve. And we also, like I said, do IT, which includes both the scouting system and the TechHOUNDS website.
I'm an outreach. I'm one of our outreach co-directors, and we do everything from demos to volunteering and hosting workshops.
And then I guess I'll go next. So I'm Madeline Sparks. I am the president of TechHounds this year. So just helping get everything organized, making sure everyone has everything they need.
And hi, I'm Emma Langlis. I'm TechHounds' vice president, and I just kind of help oversee the general team function.
Does anyone have anything else before we get started with the slideshow? Good? Okay.
Sounds good to me.
Let me figure out how to do this. Okay. Where's the person?
In the View tab, there's an option to view it as presentation
Oh, there we go.
or slideshow or whatever.
Okay. So, first of all, I want to say thank you for everyone who's here. We are very excited to share with you about our team, um, let and just help with any questions you have. So yeah, we'll get started with programming.
So for the first few weeks of build season, we teach rookies command-based Java, and we allow them to learn our library hound util, and they also get practice on the robots that they've built during preseason. During the middle of build season, like weeks 3 to 4, the design team members lead the development of each subsystem's programming, and also help continue to teach other members and allow them to help with the subsystems too. And then during week 5 and beyond, several members continue to work on refining and testing the robot, improving it and getting it ready for competition. There's also IT kind of sprinkled throughout, and I'll explain that more later. You can move on to the next slide. So as I said, we use command-based Java and several libraries such as Path Planner, Phoenix, and Photon Vision to program our robot. As I mentioned, we've also developed our own library called HoundUtil, which removes a lot of the repeat code from each year's robot by providing kind of like a template for each subsystem, and also allows swerve to be done much easier and logging to be done much easier. As I mentioned, we use swerve through HoundUtil and April tag and object recognition through Photon Vision. We also log tons of data through HoundLog, which is a part of HoundUtil, including data for each subsystem and its position. So you can move on to the next slide. Another important part of programming, as I mentioned before, is our IT, where we develop our our scouting system, which we call Hound Scout, which is programmed by us in Next.js, and this year worked on a Raspberry Pi, which connected to laptops over Ethernet in the stand and is powered by a robot battery. And we also develop our website at techhounds.com. That's all for me.
All right, moving on to electrical.
So just a general timeline for electrical is the first week we teach members a bunch of like valuable electrical skills, like how to crimp and stuff like that, as well as prepare components for the e-board, like the motors and the batteries. And then during week 2, we plan and work close with robot ops and some of their mentors to CAD the e-board. And then in week 3, after design freeze, we order the e-board. And once the e-board comes, we start assembling during week 4. And whenever robot ops hands over the robot to us, we can start putting the e-board onto the robot and also all the components and wiring it up. And then weeks 4 through 5 and beyond, we just keep working on the robot and the e-board. And once everything's wired up, we test to make sure it works. And we do drop tests, which is where we just drop the robot to see if any of the wires come apart or any like breaks or anything like that, just to make sure it can take like the hits during a competition.
Next slide.
So for our e-board design, we really focus on the robustness and repairability of it. And we want to just minimize the voltage drop from our batteries so that we don't have to run into like any brownouts or anything like that. So to minimize the voltage drop off, we reduce the battery wire length because it has a lot of voltage drop. You reduce the distance from the motor to the motor controller, which is really nice if you're using an integrated motor which has the motor controller integrated. And we plan the wire routing ahead of time, which you can see we have like a spreadsheet that shows where every single wire goes and what the label is going to be on that, as well as just minimizing connections to reduce some of those potential points of breakage. Next slide. So for our wiring, we use Anderson power pole connectors with 12 gauge wire to power like our motors and stuff like that. We use SB50 connectors with a 4 gauge battery wire for our batteries because we can get a lot more current. And then for the radio power, we used power over Ethernet, as well as just a redundant power from the mini power module. And then for our 22 gauge power wires, we use Molex connectors. And then for the other wires, we connected 2 cameras to each of our Orange Pis for Photon Vision. We used Molex connectors for all the CAN wires. And we have these 2 custom electronics. One is Hound Brain, which it was originally meant to be named Hound Brain, but yeah. So it connects to the DO ports on the Robo Rio, and it has buttons to zero each subsystem, which instead of using relative or like the encoders, we just zero every subsystem before every match, and we found that to be a lot more consistent. And then we also have Hound Hat, which converts every RoboRio port to Molex SL. Next slide.
All right, so moving on to our RobotOps manufacturing.
All right, so in RobotOps, we have to give time to programming electrical in the 6-week period so that they can work on the robot. So we have just a lot of heavy work at the very beginning of build season. So the first week is really dedicated to designing prototypes, and then at the end of that week, we test all the prototypes in a prototype demonstration day so we can see how all the different prototypes work and decide which ones we're going to use on the master assembly. The second week, we have a CAD team of about 5 students. It changes from year to year. And they'll design the entire robot in 1 week. We usually have a student per subsystem. It's typically a subsystem that they prototyped so that they're already used to designing that. And then during that CAD week, the rest of robot operations is working on prototype refinement, and as the geometry for the prototype CAD changes, those students make sure that it still works in real life. After the CAD is fully completed, at the end of week 2, or I guess sort of the middle of week 3, design team will review the completed CAD and look for any flaws or just anything that should be changed or could cause a problem in the future. And once that's approved, we begin manufacturing.
One thing I'd like to step in here and stress for the prototyping to real assembly. A couple years back, we ran into an issue where a prototype was working 100% flawlessly, and then when it made it onto the real robot, it didn't completely work. We spent the entire competition season chasing that and never really got to the point we wanted to with it. So we really stress the geometry has to be 100% perfect with the prototype, and then we maintain that geometry 100% perfectly to the final assembly as well as possible.
Definitely. All right, ready for the next slide? All right, so I'm just gonna take you through the CAD and the tech binder to talk a little bit more about the individual subsystems. Madeline, is it okay if I take over, or do you want to pull up the
yeah,
tech
go.
binder?
I will let you share.
All right. Okay, can everyone see this?
Yeah.
All right. So we're going to start out with the drivetrain. So this year we decided to go with the Mark IV N modules because of their compact design, and it gives us more e-board space. We actually used 3 of the A modules and 1 B module to better fit all of our needs. We used all Kraken X60 motors, not only on the drivetrain, but on the entire robot. And then we have custom 3D printed TPU wheels and wheel hubs, which we'll get more into later. So the frame, one of the main things about it is our aluminum was actually 3x1. In 2024, we used 2x1 aluminum. And when we took some big hits during the competition, the aluminum and the belly pan got bent, and our robot suffered from that, and we had to disassemble it to unbend it. So this year, that 3x1 allowed for a more rigid frame. And then our front drive rail is lightened for our climb, which we'll get into later, but it helps with the center of gravity. Next up is our manipulator, and the manipulator handles both coral and algae. And so it just uses basic 1/4 polycarbonate for both of the plates. And then it has a 3D printed carbon fiber cone to catch the coral once it enters the manipulator, and it also centers it. So we just use 2-inch thrifty squish wheels for the coral and 4-inch for algae. We have a figure 8 belt here at the top that we replace usually about once a competition. We at first use a 15mm belt, but that wore very fast. But then when we switched to a 9mm belt, it held up a lot better. All right, the elevator, the student that designed this graduated, so he's not here. Um, but we have eighth aluminum on we have eighth aluminum on the outside, 16th on the inside, I believe. The inside rails were originally supposed to be lightened, but after doing some simulation tests, we realized that the elevator is not going to hold up if we lighten these rails. So we kept them solid, and luckily we were still just under the weight limit for the robot. Um, the elevator itself is powered by two Krakens and a compact gearbox here at the bottom. Marcus or Coach Ford, do you
Yeah.
have anything to add?
Of course, one thing the our previous design student who designed this wanted to emphasize was originally when we built this, we were putting it on the practice field. We were running this robot a lot faster. I mean, it got faster in competition, but starting out slow, working our way up to the speeds that we wanted to at competition, we realized that the carriage had a slight tendency to fall out of the elevator. To kind of modify this, we took the West Coast Products clamping blocks on the carriage stage and extended the bearings by an extra eighth of an inch so that when there was that rotational force, the elevator carriage didn't try to evacuate itself from the robot. Other than that, this held up flawlessly throughout the season. We love our custom lightning, so but that's all I've got for that.
All right. Next up is the pivot. So for the pivot, we use 3/8 aluminum plates, and they're pocketed instead of cut all the way through so that we can have almost the same strength as a solid plate, but it's way lighter. We also specifically picked 3/8 aluminum so that we could mount the manipulator in these tapped holes up here. So we just tapped 10-30 seconds holes. And then here we have a structural hard stop for the pivot itself. Yeah, that's about all I have to say about that. We used to have an algae intake at the front of the robot, which was later removed once we figured out how to use cameras to center the manipulator onto the algae. But we originally had a problem because of the orientation of those 4-inch wheels. Whenever we tried to intake algae off of the ground, it would just knock it off to the side. So this algae 4-bar intake had the intention of sort of centering it and bringing that algae to the manipulator. So it was made with 4th polycarb. On the front polycarb roller, it had cat tongue to grip the algae.
Before we move on from this, we did move away from this, finding it wasn't 100% necessary. Quinn, Johnny, do you want to talk about kind of the reasoning and kind of how we made up for not having the wide intake?
Well, so one issue we also ran into was during our comp at Kokomo. We had issues with the cage swinging into one of those wires, as well as just the wires disconnecting because it's a moving object and it's got a motor on the moving object. It's hard to try and put the wires around it, especially when it's sticking outside of the robot. So we decided that it wasn't worth the risk. As well as with the vision, being able to center the robot to pick it up. It wasn't as necessary as it was before we made that addition.
All right, moving on to the climber. This was also designed by the graduated student, but we basically have a donut climb. If you go back up to the drivetrain, you can see this hole in the middle. That is for the cage to actually go through and the climber to clamp onto the cage. So this funnel right here will direct the cage into the center of the robot. And the manipulator and pivot come forward, so the whole middle of the robot is clear for the cage to come through. Once we've gone far enough, we back up a little bit, and then the climber clamps down, and our whole robot lifts up off the ground. So we use two Kraken X60s, and then we use steel gears for that gearbox as well. And for our climber lock, we actually used a ratcheting wrench that we had to reset every match. But the wrench sort of ran into a shaft to act as a lock for the climbers. So after the match ended, we wouldn't risk declimbing before that 3-second period is over, and to ensure that we got our points for that. All right, here is our passive funnel. The funnel went through many different iterations. I was designing it over and over every week, it felt like. But this final design ended up working quite well, and we used it at most of our competitions. We used 16th inch polycarbonate and just bent it all by hand without heat. We just used a machine in the shop. We added throughout the different iterations, like this aluminum shaft here to make it more rigid. And then this polycarb piece back here is to prevent coral from accidentally entering the belly pan of the robot or getting stuck in the robot. It will deflect it in case the human player misses if the robot isn't aligned properly. And we have a really wide funnel. It's almost as wide and as tall as our robot design could allow, so that the robot can be like 45 degrees off, and the human player can still make it into that very wide funnel. And then centers it, and the manipulator is right here to catch it with the 4-inch wheels of the manipulator, helping center the coral a bit.
Yeah, before we move on from the funnel, one thing we here at TechHOUNDS, we're always constantly iterating. That's one of those things I'm trying to tell my students. Don't fall in love with the design as soon as you're done with it. Expect to redesign it 3 more times till it's the real reason. Sarah, can you talk through some of the things we didn't like about this funnel when we were first practicing before our competitions, which made us kind of switch over to this funnel?
Yeah, our original funnel had shorter walls, and then the roof only attached to the front of the walls, and it was sort of bent up in a curve shape and was held by string. The string often came loose, and the roof would lower, making it harder for the human player to aim into the funnel. And we realized that short walls were also not great for the funnel, as again, harder for the human player to aim, and the coral could slip out, go over the wall. Sometimes it could go like over the funnel completely. And then we tried a funnel with no roof at all, just walls and an aluminum bar, and that did not work well either. We were constantly getting coral stuck on that aluminum bar, but we can't just have walls flapping around. So we were kind of stuck with coral hitting the roof and slowing us down. So then that's why we decided with this like really steep, really high roof. On to drive wheels. We tested a lot of wheels over winter break. We had a lot of different versions. And our graduated student figured out just the perfect print settings for our final version. We change them out usually every 4 matches, just because they wear down. But once they start to wear down, they don't get horrible. They stay pretty consistent, but it's best to change them out just so that we can have maximum success with these wheels. Oh yeah, we use an impact to swap the treads out really quickly. We have a team of students on pit crew that can take just a few minutes to swap out all 4 of the wheels. Coach Ford, anything to add about them?
Sure. We went through probably, I don't know, 12 different tread designs to get to this point, and then a bunch of different infill designs, and then printer settings on top of that. Sierra and Nate are really did an amazing job working through all the challenges with this. As you can see, we took a SDS Colson module just off the shelf because we wanted something easy, repeatable, something we could replace if needed, and then printed a hub around that. So that really helped us simplify the design while still letting us get full customability and everything we really needed out of it. Other than that, I don't think there's anything else really about them.
Are really reliable. All right, and that's all from the robot ops side. We can take questions about the robot later on and go through the CAD more in depth, but we have some more presentation to get to. So let me stop sharing. All right.
You can all see my screen, right?
Yep.
All right, so moving on to, we wanted to give an overview of the rest of our divisions and the rest of the stuff we do here at TechHOUNDS. Our framework director was unable to come because he's out of town. This division, it is one of our 4 main divisions. They build the practice field and the preseason competition field, which is extremely helpful for RO and PE because we can test different mechanisms, programming, every single part of our robot on a actual like accurate field size. So that way we are more ready for the competitions. They also help with the manufacturing of sponsor gifts. We will get to sponsorships later. But we like to give back to all the support and thank our sponsors for all the support they have given us. And then occasionally they create projects for fundraising events. In the past, they've made chairs, furniture, different woodworking type things so that we can sell for fundraising. Is there any TechHOUNDS, anything you guys want to add to that?
All right, so similar to our framework director, our business director was also unable to make it today, so I will kind of speak on that. Our business division on the team kind of handles most of our public relations needed matters. And so throughout the entire course of the season, they work on newsletters that we send out to parents, sponsors, and families to kind of keep them in the loop and let them know what's going on at TechHounds, why are their students gone for so many hours during the week, things like that. So during our preseason, during first semester, we make newsletters to kind of show what are kids learning, how are they progressing in their preseason builds, and then moving into build season, we talk through where are we at in the design process, where is the robot at, what difficulties are we having, so on and so forth. And then after each of our competitions, we also send out a competition recap to kind of go over how the competition went, our successes, our failures, things of that nature. Our business division also helps with team spirit, and so brainstorming ideas centered around season-specific theme for how to kind of make team dinners themed. I'll kind of go into merch here in a minute. And then they also work on the team's budget, and sponsorships are also in the business division, which we'll go over later. They also design all of our merch that is season-specific design. So I'm wearing some here. I know other TechHounds on the call are also wearing some. And that just kind of helps create a cohesive image on TechHounds. And kind of when you see us, you know who we are. And then also they run our social media and take pictures at all of our events and help work on our end of year video, impact video, robot reveal, and things like that.
So our outreach program is called FETCH, which stands for First Education and Team Collaboration Helpers. And under that, we have like 4 main categories. So we have STEM education, our National FLL Table Initiative, community volunteering, and youth robotics mentorship. So STEM education is our biannual Women in Technology workshops and our annual summer camp. Our National FLL Table Initiative is where we build FLL tables and donate them to FLL teams. We've also partnered up with 4 FRC teams to teach them how to make FLL tables so they can spread those in their community. Next slide, please. And then on this slide, you can see our community volunteering, where we volunteer at local middle schools and 26 different events. We also make adaptive push button toys, so kids with low mobility or low vision can, play with toys. And then we also mentor FLL teams. So we've mentored 15 FLL teams, and we mentor FRC team, rookie FRC teams. So we've impacted over 20 total first teams. And as a team, we have over 1,800 volunteer hours.
All right, so as we all know, FRC is extremely expensive, and one of the big ways that we raise money for the robot for the team is through sponsorships. So through raising sponsorships, it helps the team pay for our competition registrations, our travel fees, division materials, and our individual student team dues. And one thing that's really unique about our sponsorship program, it is completely student led. So at the beginning of the season, we ask of our students to complete 2 company asks in an effort to kind of get everybody involved in sponsorships and kind of make it an entire team thing so that everybody has a little part in the process. And then we also have a application-based sponsorship committee that helps submit other grants or maybe bigger sponsorships and also help design our sponsorship gifts, as Madeline mentioned earlier. Next slide, please. So the way that we kind of go about sponsorships in teaching our students how actually to complete these company asks is in the fall during our preseason, we host sponsorship workshops where we teach our students their specific role in the sponsorship process and also how to conduct sponsorship asks both in person and presentations and online via email or Zoom meetings. And really those kind of skills that they will need one day in the future when they're asking for money. We teach them that here, while also benefiting the team. And we also show them the importance in follow-ups and how to conduct a follow-up. In order to kind of increase motivation throughout the team for kind of working towards sponsorships and kind of celebrating all of their hard work, we have a general team goal for the amount of funds that we raise. And once we reach that goal, we do something fun like a team-wide pizza party, or maybe we devote a little extra funding towards something in one of our lines that students have been wishing for. And in addition to that, we do weekly shout outs and awards to kind of celebrate students that have been rising above. And then mainly our goal is to just recognize hard work and again, increase that motivation. And then our timeline for sponsorships, most of our sponsorship asks are completed during preseason, because as these sponsorship funds come in, a portion of them goes towards individual team dues, as I mentioned earlier. And so that helps them get their dues met before bill season starts up and before our dues are due. And then the sponsorship committee works throughout the entire year to complete grants in their specific time window.
All right, so in addition to sponsorships, we also raise money through different fundraising events. We do Dine to Donates all year round. We do about once of these a month. Like last month we did at Culver's, which was very fun. It was also an event as well as a Dine to Donate. And we got about $350 from that. So they are very successful and they are very helpful for our team. We also do a crew car wash sales event. So we work with Crew Car Wash and we sell online car washes, like electronic, that they can scan and be used anywhere. And we do that throughout the whole month, usually in September, October, beginning of the year, around the same time as our own car wash event, which we have a picture of here. This is where the community can just come. It's free, and we wash the cars for them. It's a lot of fun. And it's a great way for us to raise money while also building up our team community and doing more team bonding. This year, we also introduced the idea of personal fundraising pages, which allowed students to raise money nationally and work with and not just limit to our own community. Like they could ask family members or friends that live in different states to help support them and support our team. All right, so that is it for our slideshow. We're going to open it up to any questions. So feel free to either unmute yourself and ask a question, or you could send it in the chat, whatever you feel more comfortable with, and we'll answer it as we can.
While we're waiting on people to put in questions, I really quickly want all my TechHound students here just to go down the line and say your favorite part about TechHounds, or just say your favorite part about TechHounds or the most impactful thing about TechHounds. Just I'm more curious more than anything.
I'd say, go ahead.
I would say my favorite part about TechHounds is just the community that we have. I know I have a lot of friends that I've become very close with, and it's been great getting to know everybody and creating my own little TechHounds family.
So I was also going to say the community, but if I had to pick another thing, it would just be our impact to the people like we support through our outreach. That's always super fun. It's always a great time volunteering for those, and it's fun to see how we can just improve the lives of other people around us.
My favorite part of TechHounds is just being with like my friends on TechHounds at competitions, and just talking to them at the end of the day, and also just meeting all of the different teams at various competitions, especially Worlds when I can meet like some of like my dream teams. Like I just love meeting all the different people.
My favorite part of TechHounds is probably how much it's inspired me to engineer, even in like my personal life, surrounded by wires right now. So
I would
My
have to
favorite
say,
part, sorry, you go
no,
ahead.
you go ahead.
Okay, I'd say my favorite part too is just the people, like being able to, all be in the same place over like a common love for something. And then also what Johnny said, just our outreach and seeing the people we impact in the community.
I think my favorite part as well is just the community we have made here on Tech Hounds. I don't think there's another group of people I'm part of who are as uplifting, as motivating, as encouraging, and as the people here on Tech Hounds. And I'm so glad to be part of this community, and I love them all so much.
All right, so we have our first question. What is our pipeline for new students? So for new students, we do it through our high school, Carmel High School. So we post online that we have a call out meeting in August, about end of August, so a couple weeks after school started. We also go to our club fairs to help spread the word about TechHounds. And then those new students can come to the call out, learn about our team, essentially learn everything that we've shared today and more, including like the logistics of our team. And then the next week is our first meeting where we go through all the divisions and allow the students a chance to see all the divisions. And from there, they pick their favorite. And we do allow switching if they decide that the division they chose is not the best fit for them. And our biggest thing is working with the rookies, like the veterans, helping the rookies to do tool training and just learn everything about TechHound so that they, in our preseason event, so that way they are fully prepared for build season.
Quickly, I think it'd be good for each division to kind of touch on, once those students kind of pick a division, what that picture looks like for those students.
I can start with robot operations. Once students decide that they want to be in robot operations, we have like a tool training day where we just go through every tool in the shop, and a veteran member will walk a small group through how to use it, and they rotate groups until they've seen every machine. But they get the real hands-on experience when students are randomly sorted into preseason groups. Every group has usually about the same amount of like they have the veteran members are evenly distributed and the rookie members are evenly distributed. And usually The veteran members will help the rookie members learn how to use different machines or give them opportunities to design part of their smaller preseason robot. And so this preseason game is just a learning experience for all of the rookies in robot operations, and it gives everyone a chance to be really hands-on with their robots since everyone is broken up into smaller groups.
Marcus, would you like me to do a framework?
Go for it. Well, before you talk, I want to introduce a couple of our mentors on the call. Danny Arbuckle, who is kind of our framework number one mentor, and then we have David Rakovin also on the call, who is one of our main programming mentors. I think that's all the ones I saw in the chat. But yeah, Danny, if you want to go over framework, and then we'll let our directors go over the rest of the divisions.
Yeah. So in framework, first day we initially do some tool training, but we also like to do just to get students and mentors familiar with each other, learn names, icebreakers, what past experiences our students have had. And then after that, we kind of just dive deep right into maybe some easy projects. We will have them do, we'll have people build a chair in a meeting out of scrap 2x4s we have lying around, just to kind of get them ready for building the preseason field and then eventually our replica field.
So in programming electrical, similar to what Sierra said, we usually have like some tool training as well as just Quinn might explain more on this, but we go over like some of the different programs we use for programming as well as IT and stuff like that. We go over like all the components that we use electrically and all the different tools. And then also we split our kids up into different teams for the preseason game we run. And they all, along with their veterans and everyone else, they build robots to compete in a competition at the end of the semester.
Yeah,
For
so
outreach. Oh, sorry. Go ahead, Quinn.
okay, sorry. So in PE, like Johnny mentioned, people are able to get hands-on with the electrical tools after demonstration and then get feedback on how well they did on, say, a crimp or something like that. And then for programming, people learn a lot during preseason, Johnny explained. And we do timed robot programming during preseason. So veteran members are able to help teach the rookies that. And then, as I was getting confusion about only learning programming in build season, but it's more so that we learn command-based programming in preseason, and then Hound Util is explained so that people are ready to program a competition robot.
So for outreach, obviously being a rookie in outreach is a lot different than being a rookie in like robot ops or programming and electrical. But one thing we always do to new rookies on the team is encourage them to volunteer for outreach events, because that really helps our team and it really helps more people get involved in outreach is just by encouraging that volunteering.
And then I'll talk to what our business students go through when they are a rookie and joining. They are walked through how to use all the different softwares that they use to make all of our posts and all of our merch and things of that nature. And then they learn how to use the camera. And really, honestly, they just kind of jump right in business and they start working on newsletters and kind of learn by doing.
Okay, so now that we've gone through all the divisions, we're gonna go ahead and touch on preseason because we've mentioned it, but we didn't fully explain what it is. So at the beginning of the season, the fall semester, our students are split into 5 or 6 different teams that are smaller. Typically, they have, I want to say, 10 to 15 RO, Robot Ops, and PE members, and then they work together with their group leads to completely build and program their own bots. It is a slightly smaller scale than the FRC competitions, but our leadership team creates a game manual, a full game, and we have like a game reveal and everything. So it's a smaller scale of the FRC comp, and it is just within TechHounds. So that way the students can get that experience before build season. And then, so the whole semester they're working with their group, and their group leads and other veterans are teaching them how to use the tools, going through the design process. And at the end, in about December, we have a preseason competition where all these groups can compete in the game, and we find, which robot's the best. And it gives, especially rookies, it gives them a chance to get that competition experience, but on a smaller scale. And yeah, so if anyone has anything else to add to that.
One thing I'd like to add too is preseason also gives our rookie mentors an opportunity to get involved with the team. So when we have new mentors on the team, we assign them to a preseason group, which allows them to work with a smaller group of people on just building a preseason robot as opposed to a giant FRC robot.
I think this is one of those things that really sets our team apart, and getting those freshmen, sophomores up to speed really quickly. Sierra, Quinn, and Johnny, do you want to go kind of through the design process for these games and kind of how you approach these games in a way that's not too complex for a shortened time frame, but it's complex enough that they get enough experience with design and the challenge?
Yeah, we usually have just like one game piece. In this most recent preseason, we used a beanbag, and the year before we used the cubes from 2023. And it usually just involves putting game pieces on different levels. This most recent year, we tried an end game for the first time, which was going up a ramp, which only one team was able to do successfully. But everyone was able to pick up the game pieces and score the game pieces. And so since we always have a game piece, teams have to design some sort of intake, whether that's rollers or a claw. We see a wide variety of ways to approach the game since we have five small teams. And then since we usually include different levels, that requires teams to create some sort of elevator or arm to be able to lift up those objects. Um, so it prepares robot operations in a lot of ways for a build season since they have to have their robot do several different things and not just have a drivetrain. We also use more scrap materials like just leftover aluminum from the year before and old Neo motors to make these robots. Rather than buying a lot of new materials, they have to work with what they have. Gwen and Johnny, anything to add?
I guess I'll say, kind of like you mentioned, we use old components. So while we use like Krakens and Neos for preseason, we ended up using Neos and Spark Maxes for preseason. And as I mentioned earlier, it is timed robot to make it easier to understand. And it is not using our library, it's just whatever vendor libraries the team ends up needing. And it's very self-driven by the team, with help, of course.
And I do want to emphasize these robots that they're designing are quite small since they do have a smaller team rather than like our huge team of TechHounds that we use to build our competition robots. Like the frame perimeter limit for these robots is usually around 74 inches. So, they're significantly smaller, but we can still, like the students can still learn all of the skills needed for build season just with a smaller bot.
Any other
All
things
right.
before I want to really touch on this next question? Since it's currently summer, how do you guys do workshops? The reason I'm going to take this one from you guys because I want to kind of go over the administration, kind of how that works on TechHounds. We operate with 3 coaches, a head coach, or I guess 4 coaches, a head coach, and 3 assistant coaches, whom of all can host meetings. So we're very student driven team. So as long as the students want to be there and they ask us to meet, we will do our best to accommodate that. So I know our programmers have been meeting a lot over the summer to learn programming on our last year's robot and get up to speed there. As well as we've been doing a summer design challenge kind of on CAD, kind of internal, where students are designing or CADing robots from other teams this last season. So pretty much we do it on a as student basis because I've throughout my time with TechHOUNDS here since 2016, I've noticed that if the students don't want to show up, if the students don't have that drive, you can host a workshop, but only 1 or 2 students is going to get out of it. So if we really have that drive, you really have those students constantly reaching out to us coaches for meetings. It's a great problem to have. Our students are incredibly dedicated. Any other notes there from the directors?
Just been meeting at the practice field, and students can really just do whatever they need to work on for their divisions. We haven't been holding like whole team-wide training sessions necessarily, but yeah, the summer CAD challenge, it's just all virtual. Anyone on the team can participate and just kind of learn how other teams design by picking another team from this year and designing their robot. So yeah. Are there any other questions?
Yeah, I'd like to touch on what was just said in the chat. It was an amazing season. One of a kind as from a coaching perspective. We had an amazing group of students, amazing group of mentors. It's not, I mean, I've been here since 2016 and there's very few seasons that come together like this. So I'm really proud of our team. All of our students did an amazing job. And so I can't stress more how appreciative I am of these students, of our mentors, and how easy they make it to drive coach and to coach the team. So yeah, I see the next question. Can you talk about your non-coach mentors? How many, how do you recruit? How often, long do they meet, their backgrounds? Do you guys want to touch on that? And then I can kind of touch on recruiting if you guys want to kind of touch on your division mentors.
We have quite a few mentors for robot ops, and they come from all different backgrounds and jobs. Some mentors are engineers and some are just like I don't know, they have jobs that are completely different from anything related to robot operations. But that's okay because a lot of the mentors come and new mentors are just like rookie students, like they can learn the tools and learn the design. On this last preseason, we actually paired robot operations mentors up with preseason groups to kind of be a mentor for that group. A lot of mentors have really helpful design feedback and help us keep the shop a safe environment when we have all these different students working with machines. And so they're there to just guide us, make sure we're safe, and make sure we're in a positive environment.
For programming electrical, we also have a variety of different mentors. We have people who are electrical engineers who are able to provide wisdom on some interesting topics. Like we had an issue with static that they were able to help with. That was pretty cool. And we also have several mentors who do like web development or other kinds of programming, and those are really helpful.
A lot of our outreach mentors also would be considered like robot ops mentors or construction mentors. So just they all come from all different backgrounds and they are really helpful, especially when it comes to planning summer camp or planning different events. Just having those mentors to support us is just really great.
Perfect. I'll touch on kind of the recruiting process unless anyone else has anything to say for there. Um, that the recruiting process is kind of interesting. We are I don't know if we've said it yet. We are a high school related team from a large high school in Indiana. We have quite a few students, so naturally a lot of our mentors are our parents, but we do get a lot of mentors through the industry as well. So it's really a mix. This last season we used that preseason game as they talked about earlier to really train up our mentors alongside the students and start building that connection between mentors and students. So it was really interesting to see. But to kind of get the word out there, we will send an email out to all of the parents, first of all, some of our sponsors, and then a lot of other people just through connections of mentors and students, just whoever would be a good fit for the team. We all invite them out to a Saturday where we provide a nice lunch, and our student directors kind of go over a very similar to call as this one or presentation as this one, kind of explaining the team, the needs for mentors. Without the mentor background, no FRC team can run. So it's been super successful. Our mentor base has grown a lot in the last couple of years. So it's been amazing to see from a admin perspective. But yeah, that's all I've got for that. Any other notes from the directors?
I mean, the mentors, we always have like several mentors at every meeting, just helping out in every way they can. We have mentors that always come to all of our outreach events and summer camps. Like, we just really appreciate our mentors for just always looking out for us and keeping us safe and happy.
Any other questions from chat? As we're kind of wrapping this up, I want all my students. One more question for my students. What's the biggest thing you're looking forward to this upcoming season?
I guess I'll start. I am looking forward to, I guess, seeing the team in a different point of view because it's going to be my first year as president. In the past 3 years, I've been on Robot Ops. So just getting to see how the team works together collectively and all the administrative behind it, and also just creating a stronger community, making it more inclusive, and just improving our team even further.
Yeah, I'm just looking forward to seeing how like our new leadership team works together. Like I'm just really excited. And of course I'm excited for build season to roll around again and for us to meet every day and have those team dinners together.
I'm looking forward to the new leadership team as well as not being a rookie anymore and finally knowing what it's like to be a veteran.
I guess I'm also looking forward to being involved in administration, but also really excited to keep learning. I know there's a lot I have left to learn. I'm excited to do that.
Similar to Quinn, I'm really excited just to learn more, help new students and veterans alike learn more, and just keep trying to improve the team in whatever way I can.
I personally am really excited to be part of the leadership team, and I'm also most excited for competition season. I think that's my favorite part of the year.
Alright, well, unless there's any other questions, I think we're good to wrap it up. I just want to say thank you for everyone to come. We will be posting the link to the recording and the slides on Chief Delphi um, later tonight. So thank you for everyone to come, and let us know if you have any other questions. Feel free to reach out to teamlead@techhounds.com or on Chief Delphi. We're always happy to help.
Yep. I will be continuing to monitor that Chief Delphi thread for the next until build season. So at which point we'll be kicking back into Robot in 3 days for me. So uh, if you have any questions weeks from now that didn't get covered, always reach out there. I'll get one of myself or one of our students to answer it. We do not have another meeting set up at this time, but if there's more questions, we could definitely set up another meeting. I think that's definitely something we could do. Our students love to show off the team, and I love to show off the team, so it's definitely something that we could work out. So I'll answer that question. I know a little bit about 597. Some of the students on our team like to poke jokes at me for being a FRC dictionary of all the teams, or Atlas, or whatever, to knowing all the teams. So I know a little bit about you guys, but not a whole ton. I feel bad for you guys out in California. I would not want to face the teams that you guys face at every competition. So, but to be honest, I'd love to learn more, connect with you guys, and learn more about your team.
597, aren't you guys in are you guys in the Hall of Fame? Yeah, for Impact. That's really cool.
There you go, Sierra. You're going to take that away from me here soon. Thank you for coming out.
Bye.
All right, Madeline, you're probably good to end it there.
Bye bye,
Bye,
everybody.
everyone.
Hi, everyone.